Good afternoon and welcome to Venturous webinar. Venturous Group is a city tech business builder and investor. My name is Jonas Pinske and I'm a marketing advisor for Venturous Group. Today, we are pleased to have Dr. Ryan Manuel, CEO and founder of Bilby, to talk about how to predict government policy change with AI. After Ryan's presentation, we will have a Q&A, so please post your questions in the chat function so we can talk about all of the things that you want to address afterwards. So without further ado, please, Ryan, over to you.
Thanks very much. Nice to meet you all. Yes, I have an easy topic today, which is how to predict policy of AI. Obviously, it's a fairly cocky statement to say that we can do that. So what I thought I would do is just almost instantly leap into trying to prove it. And then afterwards, we can kind of backtrack and say, well, if you can do that, what next? Or, what have you missed? Or all of those sorts of things, just so it can be a bit more dynamic and we can have a bit more room for question rather than sort of you being stuck listening to my Australian accent for the next hour. What I want to sort of talk through is two things, and that's basically the art of making predictions first, and the sort of epistemological problems with that. And then the second thing I want to talk about is how software gets rid of some of those problems and exacerbates others of those problems. So the first thing I'd say is it might be useful to kind of know my bona fides, like, do I know what I'm talking about? All that sort of stuff. How did I get into this? I actually began life as a computer programmer before I went to college, to university. And then I ended up being a professor of Chinese politics at Hong Kong University, via also working for some governments. I worked for 3 Australian prime ministers. That sounds very impressive. It's actually that we changed prime ministers a lot back then, so I only worked there for a few years. But still, I through all of these things, I had a lot of exposure to this idea of kind of how are we going to basically predict things, and how can we use technology to do it? And so I think what I'll do first is just sort of switch to some software. I'm going to make a bit larger my screen so you don't have to sort of sit through all of my boring emails coming through in the background. And what we're going to start with is just the same thing a human does, which is, okay, I want to make a prediction. The first thing we nearly always do is, who is the actor involved, right? Who is, who's doing what? It's sort of basic journalism school, who, what, why, when. So where we started at Bilby was by first beginning with knowledge graphs. In other words, who are the people making the decisions? What are the entities making the decisions? What's the interrelationships between them? And then how can you use that to then bring in other advanced artificial intelligence techniques, well, big data techniques, machine learning techniques, which includes branches of artificial intelligence, to kind of then synthesize all these different ways of thinking, but add to it a lot more scale, a lot more neural networks and deep learning, and finally add to it an ability to change language. Because a lot of the barriers to prediction are not that we don't make predictions as humans. We make predictions every day. Humans are judgment machines. We do I go left? Do I go right? Do I go, like every day we're bombarded with all of these decisions, and encoded in all of us are many, many sets of heuristics, of ways of thinking. And so what we first tried to do is start with different governments and encode as many heuristics as possible, and then apply it to big lots of documents. Now, this is a lot of long words, so I'm going to switch to just something very basic and simple, which is the screen you can see with some blobs on the right-hand side is straightforward. It looks at different banks, companies, ESG activities, GIC sectors. Those of you in finance know what that is. If not, it's a classification of economic activity, so you can code what type of thing something is. Media, fairly self-explanatory. Person is a decision maker. Pilot In China, a pilot is quite useful because it tends to show what the central government wants to see, as in what's wants to have happened. They usually or often trial at local level first. And then finally, region. And so this on screen is China, except it's China in a graph database. So every bank, listed company, ESG activity, JIC sector, media, person is the top 3,000 decision makers, pilots are all the pilots that are running, and region. And so the first thing we're going to start with is a real problem of only using text in particularly when looking at political events, which is the language and homophone problem. So say I type the characters Hanzhong. As all the Chinese speakers on the call know, there are many, many different Huns and many different Zhengs, and the tone and the character, all these sorts of things affect what's going to happen. So if I just type in these two words in pinyin, we're going to get a whole bunch of sort of false positives, one of a better phrase. So it will pull through and it will find in all the bank's companies, ESG activities, that there are 30 companies that somewhere have a hun and a zheng in there. And then there's the actual person I'm interested in here. So the first sort of place to start, though, is why we always start with a graph database is once you can identify entities, in other words, I don't want to look at companies, I want to look at people. You start to, the same way we do as humans, layer on top of that the biographical and metadata, the other information about a human. And again, this is very normal in prediction. You know, if I predict something's going to happen because Xi Jinping says it, you'll take it more seriously than if I predict something's going to happen because some mate I met at the pub yesterday said it. There's always a level of hierarchy embedded in prediction. And one of the problems with large language models as a form of predictive analysis, of course, is that you can't embed hierarchy very easily into them. It's very difficult. And so by starting the other way around, by starting on the graph database side, what you do is if you want to pick a person, so we'll pick Hanzhong, you straight away, you know about him, all the things he's a committee member of, where he's a party head of something rather than the government head of something, which areas he's meant to be talking about, when he was born. And so let's look at where he was born, say. And then suddenly technology has a huge advantage. Once we've gotten through that sort of problem where tech isn't so good, as in the Hanzhong issue, whereas a human being, of course, even if I get my tones wrong, even if I have the wrong characters, you'll be like, oh, you know, that politician, you know, that Hanzhong guy. Humans will instantly get what we mean. Computers won't. But once you have the entities matched, you then have this advantage of having the biographical information. And of course, you then have the biographical, you have that available for all entities. So Hanzhong was born in Xixi City, for example. Here are all the other leaders that were born there that are decision makers. Here are the companies that are headquartered there. Here are the pilots running there. And there's just no way a human being can have this level of depth of information at your fingertips for different actors. So there is an advantage in using technology and using AI in particular to predict, firstly, because it allows us a very deep entity level, deep learning approach. So going back to our example, we now know all these people who are linked to Hanzhong, say. But the other thing that's wonderful about using tech is you can construct the matrix in your head of where everybody sits and how they're interacted for all, I think it's 66,000 things on the right-hand side. But anything, so we'll click one, we'll click a random person. For all people, you can see the paths between them and you can measure the distance apart they are. Now, why that's so useful for prediction goes back to my point before about Xi Jinping versus bloke at the pub. If you can see how important an actor is that's making any sort of statement, and you can pull out those entities and pull them together, you have a vast improvement in terms of your ability to say what comes next. And the reason for that is because, like, you know, most people are hierarchical when it comes to following orders. You listen more to a general than to a corporal. You listen more to the top leader and act than to somebody who is at your level. And no matter the political system, that is a fairly well-constructed rule. And so, you don't want to waste your time. And so by being able to see where every actor is vis-a-vis other actors and weight their importance, you have a huge advantage when it comes to predicting their activity. The other advantage you have, of course, is you can then layer that information into whatever you put out into the world. And that becomes useful because as Venturous has shown very nicely, one of the real powers of tech is when you link different models into a feedback loop, i.e., when people use your product, they click on things, you get that information back to you. That actually helps train and train and train and train and improves the validity of your predictions themselves. And so where that looks like here is, let's switch to a very boring, straight up and down memo. I'm in Dubai right now. I was in Saudi Arabia last year, and they said, "Oh, can you tell us what China said? The Chinese government said about us." I'm like, sure. And so we sort of wrote a nice, straight up and down report of what different parts of the Gulf were saying about what China was saying about different parts of the Gulf, based on all of its publications. And again, going back to before, because we have all of these banks, companies, ESG statements, activities, actors, all interlinked, you then have the ability to track and collate everything that is said, or whenever they're mentioned. In other words, you can keep an eye on what they want the world to know, because all leaders want their orders to be followed. They want their public statements to be acted upon. Otherwise, you would make them in public. And so that sort of methodological principle means that if you have to write a memo, something like this, for example, you can interweave into that actual, quite simple, often political judgments. And so in this case, we'll be like, who is Han Zheng? Is he important and should based stuff? And it will pull through. And then rather than just give a straight up and down thing of being like, well, this is what he said when he went to the Gulf or whatever, it will actually give you some defined analysis. Simple, but based on trackable parameters. So you can see here, he is a prominent politician. He's a vice president. That's largely a ceremonial role with no delegated powers. Therefore, don't think that he can make decisions necessarily, but he has access because of his old connections. Okay, fine. So that's fine. It's a good, simple, fast analysis. Where the tech, it's quicker than sort of a first-year analyst. You'd probably hope the first-year analyst gets into a bit more depth, all those sorts of things. But where the tech really starts to shine, of course, is that then you can layer things on top of that. You can ask, what about the guy he met? What about the meeting he had? Would that be useful to me? Okay, suddenly things get a little more interesting, because we can now see who he met, how important that person is, what their role is, if it's useful for me in a Hong Kong-based startup, say, to meet with this person in the UAE. And you're like, okay, their meeting, what did they talk about? And should I care? Sorry, the typo, I mean, that may not work so well. And so what you can see here is that we've started on layer one of forming propositions that can make an analysis, right? So this is what they talked about. This is what it means. This what might happen next. Cool. What then is able to be done with that sort of layer one thinking of, this is who the person is, this is how important they are, is that then you can also take what they say. And here, obviously, you have another level of AI that is very handy. And so what I'm going to shift to now is looking at sentiment and language. So I can sort of see a few people in this call, I imagine, speak Chinese. Even if you don't, it's pretty simple to know what's going on here. This is a political statement coming out. It's a speech. It's about culture and health and various other things at an important forum. But what we're going to do is take the text of this and we're going to try and analyze the text. Except rather than just analyze the text, we want to layer into this awaiting, we want to layer into this and see what is, what should we take away from this if we're a party official versus a government official? What should we take away from this if we are an international company or a legal, So you can see here that what we've got is different types of language. And so what we're going to ask our tech to do, and again, this is all sort of the behind the hood workings of making a prediction, is take out the party and the government language and reweight the sentiment so that we can basically be like, oh, well, this is what I think it means for a Hong Kong startup, say, or a Dubai multinational, based multinational. And so running this sort of text-based analysis, again, it really improves our political predictive power. Why is that? Because we can start to match not only where people sit and who they are and how important they are, but we can also match the types of language they use and the things they say, and actually pull out and be like, okay, I don't just want to know what all the important people are saying. I want to know what the important people are saying that is focused on the operations of government rather than, say, the operations of the party in China, for argument's sake. And so you can see here, by taking out the party and the government language, the original sentiment of this document, if you just want to look at it as in like, how positive is it versus how negative is it? Is it sort of saying everything's wonderful versus you're saying everything's a bit rubbish? 0 is the most negative, 100% is the most positive. By taking out the party and the government language, it recalibrates it from being clearly very positive to being a bit more in the middle baseline. So I, as an international actor here, looking at this document, would be more looking at a different bunch of sentiment for it. And so you can see the other advantage is you can look at how confident the model is in terms of its predictive power. Models have a wonderfully self-QAing function. We can talk more about that in the Q&A if anyone's interested, for those of you who have more technical backgrounds on the call. So suddenly, though, you can see that we know where people sit and we know how they act, we know what they've said. So the next step is we should put that together. And here I'm going to switch to a more broader terminal. So this is just a piece of experiment. This is showing what happened in the last week in, I think this particular country is China. I'm going to stick to China at the start and then switch to other countries in about 5 minutes, and show how this system actually can be retweaked for any country or any hierarchical entity. But you can see here, so this is the last week. So there's 26,000 things that have come out in the last week. It looks at different sectors. Now, because we've pulled all of the statements of all of the actors we looked at before, and because we can label all the documents and match them, we look at the sentiment, we look at their positive, negative, neutral. You can obviously go through the documents, but there's 26,000 of them. I'm not 100% convinced on that personally. Let's pick one. So this is sort of automatically translated into English for us. And then if you want to, you can obviously take any document and you can have a nice, useful automated analyst. Please summarize this. And you can bring in those documents and have a much broader palette of analytical predictions be able to make, because you can output it in any language and do various things with it. I'll just let that do its thing there. But the main reason for the question I was asked to talk on, which is how do you predict, is that you can classify things by their sentiment and by their, oh, here we go. Never do a demo. Doesn't seem to like the Arabic translation. I'll get back to that in a second. So you can classify everything by its sentiment. So we showed that already. You can classify things by how important the people talking about them are. And then the final one here that's quite interesting is you can classify things by where they sit in a life cycle. Now, when we say a life cycle, what do we mean by that? Is that, basically, I'm going to switch screens here and hopefully it helps. So the static view of China, how it functions, the different ranks, different orders, how it goes down, how the different documents function. We've sort of talked through this dynamically. This is static representation. And now what we're looking at here is a policy. So a policy here in this particular case is Belt and Road over 2 years. And now you can see that it's actually chronologically tagged the actors and the way that the actors express themselves in a way that you can see 1, 2. So if you look under speeches, which is on the left-hand side of the diagram, just below the thing saying stimulus, you can see that the first thing that happened on Belt and Road here was a speech. And then next to it is a 2, which is where it got put into the 5-year plan. And then if you go down to the bottom under ministries and under provinces, there's a 3. And you can sort of count up the dots. And again, we can sort of talk through this for a while, but the idea is very simple, which is if you know what people are saying and the sentiment, and you run clustering, you can run a discrimination algorithm on what all the different parts of the system are saying, you actually have a sophisticated way of knowing where something is in a life cycle. Is it an early signal or a late signal? And so I'll go back to the software in a minute. So because it takes me a little while to sort of jump between screens. But so what that allows us to do, you saw before on the screen, is for any sector, person, entity, whatever, you can see comparatively day by day how its sentiment changes. In other words, are governments saying more positive things about Russia versus the US today? What about last week? What about a year ago? What about all those things? You can also see how important the people talking about stuff are, because you have them all mapped and ranked in various forms. And then finally, using actually machine learning to teach on the theme and be like, right, for everything that mentions Belt and Road, go through and match, extract the entities, match the entity against the database, then look at the corpus of text and see how positive and negative is. And then finally, chronologically date stamp each of those statements, and so I can know when they happened. You have a synthetic index, in other words, of whether something is an early or a late indicator. Now, when you put these three things together, obviously you can never predict the future. It's impossible. But if you are able to say how important actors speaking about a theme are, whether they are saying early signals or late signals based on analysis of past statements, and whether or not there's a history of that pattern happening or not happening, you are able to be, in essence, more predictive. And that's when we say that you can predict policy with AI. What we're really saying is you can much more accurately tell where in a general massive state of affairs the world is. And then that allows you to make very specific empirical predictions that then you can then test. Prediction is hard, especially for the future. So you're going to get things wrong, particularly things like timing. All we can give is confidence intervals, i.e. the last time we saw this happen, it took 3 years for the full cycle to play out versus, and then maybe the next day somebody makes a very important statement that means that suddenly a 3-year cycle becomes a 3-month cycle. And in that sense, the prediction is empirically wrong. But the thing that matters most is not whether you're right or wrong at the start. What matters is that you have a corpus, a body of decisions, a body of predictions that can be tested against those decisions. And finally, a body of evidence that you can test against. And then what that means is if you then link it to software, whatever people, whatever gets trained into the system can self-train, the system can self-improve. And so that is where we've seen real advances. We've been sort of making various iterations of the algorithms for about 3 years now. We've seen quite significant advances based on bottom-up feedback and self-learning that hasn't been driven top-down, in other words, by someone programming into a machine. Now, this is great. I focused just on China. I promise I'd look at other countries. Before we leave the PowerPoint, it's worth noting that this system can be applied for many other countries as well. So let's say, look at Indonesia, similar idea. You can do the same thing in Vietnam, similar idea. You can do the same thing for the EU. You can do the same thing. Here's Germany. You can look at India, you can look at Japan. There's many ways that you can cut this using this methodology of a graph database, in other words, a way of mapping all the different entities and the knowledge, and then the documents they put out matched with sentiment tools. And so to look at that again in a dynamic sense, let's switch back to our software. And now instead of looking at China, oh, actually, before we do that, let's look here. And remember I was showing before that you can see sentiment, importance, and policy lifecycle. And so what this particular platform that's made for somebody who's dealing in the markets, they want to see things just at the broad MSCI category level, so communication services versus other areas. But you can see here how the sentiment differs and how the importance of actor can differ. And finally, whether you're seeing more early or late stage signals coming out differ. But the other thing that's wonderful about that is it actually surfaces information for us. And again, getting to this predictive nature. So you can see here, there's a bunch of different themes: party ideology, green, industrials, education. And you can see where the policy appears to be very stable. There's not much change. There's not the early warning signs we see of change. And you can see that across these different actors, you can actually have a running dialogue trying to find unknown unknowns, where rather than top down being like, I'm really interested in what China is saying about green tech. Instead, you're like, well, green tech looks like it's in a position right now where there's likely to be change. And that prediction is actually surfaced from the algorithms themselves. So rather than us saying like, tell me what will happen next week on green finance, make me a prediction, where what you're going to get is a body of documents and an index and the deviation on the index. That's good, but there's always a problem, of course, with predictions that by the time you go and search for something, you probably already have a prediction in your head. If you go to a piece of software and you say, hey, predict what's going to happen on green finance, there's already, it's a known unknown, so to speak. And there is actually a methodological bias of that, of you can be surprised more easily because you've already read something that's put that in your head and you've already made that prediction. Now, what's wonderful about having such a system based around AI that is that it surfaces actual predictions. In other words, we think that green tech will, is more likely to change than, say, consumer discretion or e-commerce. And that then there's a body of documentation, there's a bundle of documents, you can see there's about 6,000 documents that are attached to that prediction that then you can actually, through an API, you can run tests against. So you can see here we have our API that's constantly running. This is the China one. So there's about 3,000 documents, say, coming in where they're part of a predictive bundle. So every time something comes out, it automatically gets tagged with all these different scores. But also you can see where bundles of predictions are made for various commodities, or bundles of predictions are made for various sectors, and you have a much bigger corpus to test on, and you have a fairly rich array of constantly coming in signals that are themselves predictive. Again, that doesn't guarantee that they're going to be right, but it does mean that you have a testable baseline index that goes back 7 to 10 years that you can be like, okay, this is a change and these are the patterns, and you can back test, so to speak. Finally, I promised to say, look at a different country just to show we don't just do China. Now, partly why I pick India is because it looks so different, right? Like everything we've looked at with China, very top-down country, traditionally thought of as a top-down country. In other words, if Xi Jinping says something, it's probably going to happen. But more importantly, as well, as you saw by the structure diagrams, what happens in the center, there's a central system, a provincial system, a prefectural system, a county system, township, village, people, and it's nicely structured. And so you get sort of signals being passed up, down, but still there is that structure. Now, India is not traditionally thought of as structured. There's one other thing that makes, of course, India very difficult if you're sort of like, oh, well, let's just use the China models. which is that you don't have you have a national language, you have English and Hindi, but you definitely at the local levels, you do not have the homogeneity of language. What's published in Shandong at the provincial level will be in Mandarin, as in Guoyu Putonghua, whatever sort of phrase one wants to use to discuss it. It is in standard Chinese. And that is the same at a village in Shanxi versus a prefectural level, Bureau of Finance in Shandong. That does not apply at all in India. The great thing about tech is that if we follow this use of language and graph database, and knowledge graph, you actually can retrain it for India in a completely different way, but have that same ability to be predictive. And so to show you exactly what I mean here, we're going to look at a foreign company in India, and we'll look at who regulates them centrally. Now, here you can sort of see a bunch of blobs coming out. So let's look at, say, Abbott Labs. Abbott Labs is regulated by the Ministry of Health. These are the decision makers in the Ministry of Health centrally. At that point, you're like, well, okay, that's sort of looks a bit like the Chinese system. You're like, yeah, that bit does. But where this becomes very interesting is you could see in China where you can look at different peer group effects through where people are born or where people worked or where people went to school, things like that. In India, you have that same ability of associative sort of analysis that allows you to make predictions, except it functions slightly differently. So here you can see this person's called Sudhansh Pant, and they are a central bureaucrat in the Central Ministry of Health. What's fascinating about that is that they entered, the central bureaucrats, the decision makers are what's known as the Indian Administrative Service. So you can see here they're these bureaucrats. They're not elected officials. Rather, they're appointed top down, and they have to do everything in English and Hindi. And they also have this interesting quirk that they, the year that you're into that administrative service, all of the people that are accepted in that year all live together for 2 years, and then they're all sent all around the country to lots and lots of different places. So then if something happens, you have this instant network of people to call around the vast Indian government. And so here, let's look at Sudhansh's, where, for example, their group is. So this was the year that they entered into the administrative service, 1991. And these are all the other people all spread around the country that are in that network. And again, the same as before, you suddenly have that associative power of knowing how far away different actors are from each other. So that is the one interesting use of tech that I wanted to highlight where India, but it doesn't solve the language barrier, right? Like it's fine for Sudhansh, they're a central bureaucrat. We know they can do it in English and Hindi, but what happens at the local level? What happens in the sort of, in Maharashtra, say? And this is where tech, again, has such an advantage for making predictions. And that is because let's look also at where Sudhansh grew up, and let's look at all of the elected officials, in that area. So these are all of this is a completely different group, right? They're not centrally appointed. Rather, they are locally elected. And so their incentive set is completely different. They do their work not in English and Hindi, they do it in the local dialect. They don't use PDFs and publish things on websites. They do things through radio, through media, through their face, all those sorts of things. Now, to a human, that is really, really, really difficult just to get your head around, let alone analyze, let alone predict. To a machine, this becomes much cleaner because what is said in Marathi and Maharashtra by an elected official, which as you can see, we track, versus what is said by a Maharashtra official in the IAS in Delhi in English or Hindi, the delta between what's being said in different languages itself allows you to make predictive statements, i.e., this is what's being said in the official dialogue in the IAS in English, in PDFs, but this is what's being said in Maharashtra, in Marathi, in Mumbai. And by the way, and you can see here, again, we map in all the companies, we map in the Nifty 50, the Nifty, all these things. So you look and you say, well, in that case, you're going to see a bigger impact on Reliance in their headquarters in Mumbai than you're going to see on I think Tata's also a member. Then another big conglomerate whose headquarters are in Delhi. And so, or another area in Gujarat, say. And so this is this systematic way of compiling a nation that allows you to, again, go through any regulation, see through what's happening. Please tell me based next month that might affect Morgan Stanley from making an investment in an Indian SOE. Say, right? So it will pull through all the SEBI, also the Reserve Bank regulations. It will look at what's important. It will look at what things might come next. Again, just based on linear progression, all those sorts of things. But then you can also map that against what's being said about these factors locally. So here we go. It's going through all the amendments now and compare it with, tell me what's being said that might affect that Indian SOE acquisition or investment in Maharashtra or in Mumbai, which is the capital, main city of Maharashtra. So this combination of being able to map actors, look at what they say, pull it together, go back in time and spit it out. It's very powerful for predictive things. There's one final thing I'm going to very quickly talk about. I'm definitely on time in about 40 minutes now, which is well and truly too much of my less than dulcet tones. Of course, if you have different countries, you start to get predictions by looking at what different countries say about each other and the timing of that. So say, what is the US saying about Japan? What is Japan saying about Vietnam? You can actually start to synthetically be like, rather than look within India and what's different about what's being said by an IAS official in the center versus what's being said in Maharashtra, you can say, well, what's being said in the US and how will China respond? Or how is Indonesia going to be affected by tariffs that are being imposed on China? Because Indonesia is also under, say, the Inflation Reduction Act. It got hit quite heavily due to some of the wording, right? So all of these sorts of things, again, there's no such thing as a perfect prediction, but there is an ability to weight the game in our favor by saying, this is what has happened. This is the trigger, i.e. a US government statement is the trigger. But this is what happened when similar US government statements were made in the past. And algorithmically, therefore, this is what we think is the most likely thing to happen. And that's where we're this is where we are today. So this is right now. Clearly, there is a huge amount of scope to keep growing this field and to make more and more predictions, to be testing. We're pretty happy with where that is now. And we think there's a huge amount of potential in the future. Where obviously this fits in particularly well with what Venturous is doing, and we've always been excited talking to Venturous, is that it's a similar idea when we think about knitting different portfolio companies together or different parts of cities together or city tech together and forming synthetic data streams that allow you to be predictive. So I obviously look at it using a different way, as in using a different bunch of tools, but that same idea of how do we pull together different streams of data, both top down, as in, we know what should happen, and bottom up, i.e. this is what we're seeing from the data coming out from the ground. It really is a sea change in terms of how we think about predicting policy, other factors as well. But I'll probably stop there and pass it back and see if we have any questions.
Thank you, Ryan. I mean, there's a lot of things to unpack. We got a few questions. I'm going to just look into and see if we can cover some of them. One is, of course, about the predictability, right? The accuracy of what you're trying to predict. If you're looking back to kind of what you have done over the past year or two, how accurate would you say that is? And have you kind of tracked that and come up with some kind of percentage?
We have, but only for different fields where people have paid us to. So we're a bit biased because those fields have done well. So it's not really an accurate thing to be like, oh, look at us, we're so amazing. But where we hit very nicely is direction. We haven't had any, that's a very high confidence within our own models in terms of seeing what's happening. That makes sense because governments are constantly talking and they're saying blah, 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 blah. Where we're really working hard and it just gets tougher and tougher is estimating timing changes. So, for example, we've been on the record for a long time on various things where we were quite early callers of policy changes. A very good example was COVID reopening, where I sort of got mocked a bit in the Financial Times because one of my mates called me up and said, "Oh, what do you think's going to happen?" And I'm like, "Oh, this is what I think is going to happen." And then he sort of stuck me at the bottom of his article, being like, "And some people are much more confident. Like, check out this guy, Ryan." And I was like, "Oh, thanks, mate. Like, you really, yeah, you could have been a bit nicer to me there." But then a few months later, they came back and they're like, "Oh, actually, that held really nicely." Um, Similar with pharmaceutical crackdown in China. Again, we saw that happen. On both times, though, where it was tough for us was getting that timing exactly right. The pharmaceutical one was a lot easier because they said this is when the regulations will start, and it just got overlooked by sort of various commentariat. So we looked really smart there. But say COVID reopening again, rather where I think we need to constantly improve is it's like, well, Q4 or Q1. Q4 or Q1 isn't, I think, methodologically good enough to say like we predicted it perfectly. Like we where it's getting tougher and where it's getting tougher is that timing. The other area where I don't have the data yet, because literally we've made the different country models and now we're starting to put them together, and that's a sort of moving feast, is the cross-country comparisons. Because it's a different, training a system to measure itself and check its weights and biases cross country is my other big focus. So yeah, it's sort of I'm obviously quite cocky, otherwise I wouldn't be talking about it. But there's so much room for growth, and I really feel like the one of the things I'm excited about with the cross country model is that it will improve the timing also of the domestic political models. And to be more precise, if the US says we're going to tariff everything or tax everything, there will be a reaction in China, and it will force certain decisions forward. And so my hypothesis is that some of the timings that we've not been as good on, as in this is how it happened in the past, is been because there's been an exogenous shock. There's something has happened overseas, and then that isn't baked into our model yet. And so where, again, the tech will hopefully really shine is when you start being like, okay, that's what we predict happening. Now tell me what happens if the US says X, right? Go back in time and show me when the US said X and what happened next. And that's, I think, going to really also improve our timing confidence intervals. But I don't know yet. Like, that's the true answer. So yeah, it's part of the fun, right? In terms of direction, though, it's like shooting fish in a barrel. So, like, I mean, you
Is
just
this
you,
not what you predict for like the next, let's say, 2 5 years ahead? Like the tech would be so advanced and integrated that you could actually do, serious modeling about this is what happening now, but what X, Y, Z would happen, how that would come out. Like scenario
yes.
planning for the future, right?
Yes, exactly. But that sort of scenario planning, again, we haven't been running as a company that long enough to sort of brag about that yet. We got a whole bunch of stuff right that's been 3 month time windows or 6 month time windows and stuff like that. These are often big calls, but where it's just going to take time, and that's part of the fun, is looking at things like 5 year plans. You know, on a 5 year plan, you know, predict all that sort of stuff. And that's where we can give back tests only. But the predictions we're making today, you're not going to see the actual results of it for another 3 4 years.
Hmm.
Um, that doesn't mean that they're not happening. It's just it's an interesting kind of tweak on the whole thing.
Another thing that came up here was about like if you're a company who wants to start using this kind of technology. I mean, it seems like almost like an overwhelming amount of data that you can kind of section and subtract. Do you or like come in as a consulting or advisor on how to subtract data and ask the right question or prompt in order to get what you actually need from the system?
Yeah, I mean, that's how we started. And we did a lot of that sort of almost software enabled services work to build it up. Where, of course, we're going is that there has to be that self-service. And then you could see that with the different bubbles showing different sectors coming up. Um, Again, we're a software company. And so pushing this out in that sense in the software is always going to be a challenge for us, right? It's just so much easier to say like, oh, you're interested in pharmaceuticals. Well, we'll do all your modeling for you, and that's definitely how we grew. Um, the other area though on where things can be built, where the world has really shifted and has kind of shifted in a way that I think has helped us as a business, is that we supply all of our data as an API, and that a few years ago or a year or two ago wasn't an easy sell particularly to say a multinational. There's one particular company, they're a longtime partner of ours, they're quite advanced in their field, um, Fortune 500, et cetera, et cetera. And I went to talk to them and sort of like persuade them to like, yay, our contract's great, give us more money, woo. And they're like, look, this is great what you guys do. But the problem is that you're on Mars and we need to shoot for the moon, and all this Mars stuff isn't very useful to us right now. And I'm like, yeah, very good critique. Right? I mean, that's part of prediction is if you want to predict right, you often have to go, you overshoot, right? And then you have to backfill, partly through services, as you rightly know. What was really interesting though is when I went back the next year, and they did give us more money, so thanks for that. They said we have a full internal AI system now. And suddenly, rather than being interested in talking to us because, we could email them a report every week as to where something was and what we thought would come next, they were much more interested in talking to us as a way to build self-learning systems that they could plug into their own internal AI. And this was somebody that literally, it wasn't even 12 months, it was like 10 or 9 months before was like, hey, Mars guy, we're not even thinking about going to the moon. And so I feel like this is one of those things where there's actually a real convergence. I think that the advances that are happening with particularly consumer tech, and driven by people like Venturous and their portfolio companies, is meaning that big companies are becoming much more sophisticated consumers of information. And so what before we had to do, to get a contract in order to show that we're not full of hot air, was be like, oh, look, I'll be the buffer in between and I'll do that. That I don't think that assumption is as true today. And I definitely think in, say, 2 years' time, that assumption will not hold. Like, I really feel that it was very, I mean, anecdote is not the plural of data, clearly, but that one anecdote is a very elegant example of where when we talk to governments and multinationals, as opposed to, say, quant hedge funds or systematic traders, they're the conversation, even month by month, is getting more and more sophisticated, and that's helping our business model because it's it shortens our sales cycle and means that we can get more people making predictions and get testing straight away and trying to prove that we're right, and showing value straight away. So historically, yes, but I really think it's changing, and in the future, I don't think it'll be like that at all. I think it's APIs talking to APIs.
All right. Another thing here is, of course, AI, and we talked about, the models being, hallucinating or becoming off tangent or transparency. How do you kind of make sure that it's intact in terms of how your model is processing the data and coming out with an output?
The way you do that, I mean, the thing is that a hallucination is inherent in a large language model, just epistemologically, right? Now, the best rate is about 3%. And then obviously there are ways you can tune that by doing a thing called RAG, as in, sort of focusing down, but even then you get it down to about 0.3%. All right. So it's a 10x improvement, but still. You can't stop that. But what you can do is, one, you have a very clear audit trail. And that's the other real advantage of using the method we do, which is graph rag plus normal document rag, is that actually for every, set of, bundle of predictions, you have the full, you could see when we said this is where we think it is in terms of change, these are all the documents, right? And that allows tech to self-improve. Now, you can't, you can't magic away a problem, but what you can do is try and auto QA a problem. And this is where I feel like, the world, we had this big leap in terms of consumer acceptance of LLMs, that sort of like Moon Mars thing I was talking about last answer. But with that, that's actually old tech. Attention is all you need came out, what, 2014, 2016? I mean, this is not, Transformers aren't new tech. They're actually quite old tech. And even RAG is, what I'm trying to say is that sort of we have really, really powerful, big, giant dinosaur beast LLMs already available to us as LLMs. But where the future is lots and lots of SLMs, lots and lots of small models. Again, some graph databases, some, it's this synchronizing of methods. It's this matching of different types of machine learning, and then building on top of that, like auto QA that gets you around it. When you sort of talk about hallucinations, it's like, well, each model as in each type of model has its own problems. If I run a supervised machine learning model, well, you can get less hallucinations, sure, but you're also not going to get some of the real power that you get from doing, neural networks or something like that. Vice versa, though, if I am talking to a law firm and they're like, our entire business is no hallucinations, you're like, well, then why are you using an LLM? You can't override the programming there. But what we can do there is be like, well, you're a law firm, you've got practices, you've got different practice areas, you've got different partners. Why don't you build lots of SLMs, and then your output device you can link on an LLM, but you have an audit trail of that, and suddenly things get better. And so that's sort of our answer. It's not really an answer in some ways of like there is some magic bullet. It's not. It's that we auto QA, we make models to tune our models, we make models to check our models. um, but at heart, we always have an audit trail, and we always have a bundle of documents. And even if today Bilby can't nail that and it gets things wrong, like future Bilby will be better and it will get less things wrong, just because you've got that audit trail and it's testable.
I mean, it's interesting to see what will come out of this. I mean, it seems like right now this might be the competitive advantage, getting interesting and relevant data and predictions, but giving it 5-10 years when everything is connected and subtracted, and the models and the data will be even more forceful.
Yeah.
Everyone will have access to this kind of modeling and prediction. What's the long-term prediction of this in terms of competitive advantage?
That's what we want. We don't want to be like the smartest genius, galaxy brains that come in and be like, your model's better than your model. It's the opposite. We want it to be something that people build on. Like, why do we make it available as an API? So you can do your own stuff with it. We don't, that world of expertise is really changed. Like if we presume that what I'm talking about is true and I'm right, and I think I have the facts to back it up, my job as a professor is over, right? Like, oh, look at me, big brain, sort of standing in front of the classroom, and you have to believe me because I have this fancy title. Like, that just doesn't work. And that's so exciting from a improving the field perspective. But if you want to sit there and be like, oh, well, my brain's bigger than your brain, I think you're right. I don't think that's going to hold. I don't see us as this sort of unique source of insights in the long run. I see us as having a really clean, open platform that other people can build on that plays really nicely with what other people do. And that's how you win, right? Like at heart, make something people want. If if I just say, oh, well, this will happen tomorrow, and you say that'll happen tomorrow, like we don't actually know who's right? And I think part of, if I can really be a bit overambitious, part of the issue of political discourse is just as we've made more and more predictions and there's more and more shouting, you have to make a sharper prediction, a more over the top, oh, you're wrong, a more heated statement in order that people take it seriously. Where we've moved away from testability, we've moved away from empiricism, and in historical terms, like when you swing too far in one direction, you always swing back. I really think there will be, the reaction to Trumpism, say, is very boring, careful empiricism. Like you can't outshout, but you can small marginal gains, lots of APIs, lots of different actors that are knitted together in a system that are talking well with each other. I genuinely think that's where you'll get such better, you'll get those 10x results, you get much better outcomes in a way that we want to be a part of that system. We think that we have a way that people can build on it that can be the backbone of that system, and that's what really excites us.
Our hour is soon coming to an end, but last question: if you were to use your system to predict something for next year, what would that be?
I don't think the Chinese will crack down on rare earths. There's been this really interesting shift in dialogue in terms of counter tariffs. I only say this because it's quite testable and I can say exactly the things. There is this shift away from, but every time I read about Chinese reaction to these, tariff impositions, it's always, oh, and they'll crack down on rare earths and things like that. That is not what we're seeing in the discourse at all. Rather, what we're seeing is specific mentions of, different metals, things like that. The future will not be kind of, I have X and you have, and I'll stop you from buying it, so much as being like, I will squeeze your supply chain thus. And I think a lot of that is not baked into the price when we think about traditional trade wars, frankly, which is that, if you put 60% tariffs on China, well, you're not going to get less Chinese solar panels. You're just going to get more Chinese solar panels that are made in Malaysia, Vietnam, or wherever doesn't, like capital and tech and things like that flow really smoothly often. Well, that's not true. It's really hard to rework supply chains, but it is very easy to say, oh, I don't want this robot to be made in China, so I'm going to ship it in 2 parts to Las Vegas and, to Nevada, and someone's going to screw those 2 parts together and voila, made in the USA. Like, I think that the Chinese discourse is that they have baked that into the price now, and they're saying, we don't do tariffs, we don't do anything like that, but rather they'll squeeze on specific items within a supply chain that will not fight fire with ice, so to speak, rather than fight fire with fire. So yeah, mark my words, vanadium, things like that. I can go through them all, but we've reached 6 o'clock. So
Right. Let's from a year from now, let's see if you were right or wrong.
I'll do another session.
Exactly.
Everybody will be like, that guy was terrible. I'm not going to that. He was wrong.
Thank you so much, Ryan, for sharing your insights and expertise and knowledge around this very exciting topic. For everyone who's listening, you can see this recording on venturousgroup.com to go back and see if you want to know something more specific about being said. And going forward, we will have more exciting topics coming. So stay tuned for more interesting things about AI and the city tech coming forward. Thanks again, Ryan, and have a great afternoon or evening wherever you're at in the world.
Thanks all. Lovely to meet you. Bye.